So hello everybody, welcome to the webinar. Today's topic is simplify your CNI projects, live demo of Canadian Solar's design tool with modules and inverters. My name is Marian, and today me and my colleague Nicolas will guide you through the following slides. So welcome again. First of all, general information. All participants are muted and in listening mode. The session will be recorded and emailed to all participants. We'll have a Q&A session. To ask questions, please use the Q&A window separate from the chat. If you wish to ask a question anonymously, you can configure it by checking the corresponding box, as you can see on the slide. So let's now move on with the next slide about Canadian Solar Company and our portfolio. Canadian Solar as a company was founded already 24 years ago in Ontario, Canada, and since 2006 we are listed on the NASDAQ. Our solar module capacity is on the level of 51 gigawatt, and you can also see or read further statistics about further capacities on our site, as well as a number of countries where we have where we are active. So far, cumulative module sales, modules delivered globally is more than 165 gigawatt, and we already delivered globally more than 13 gigawatt hours of storage solutions. Canadian Solar was also achieving various awards. For a very long time, we are Tier 1 manufacturer. We achieved Sustainability Reporting of the Year, as well as the Seal of Excellence for Sustainability. Now, let's have a look on some structure. So EMEA, HQ, our headquarters is in Munich, Germany, and we call ourselves Global Local, which means we are globally present, but we are acting locally. We have more than 140 employees and over 45 nationalities, which means if you contact us, in many cases, we speak your language, which is very important. EMEA team is realizing shipments to over 90 countries, and this is statistics for the previous year. We have 4 offices, 5 warehouses, and we've been always among top 5 module suppliers. Let's now move on to our product and application portfolio. Maybe for many of you, Canadian Solar is a well-known module manufacturer, but since quite some time, this is not true anymore, because Canadian Solar manufactures high-quality modules, as well as inverters, and also storage systems for every application. As said, we are not only module manufacturer, but in our portfolio, we find our own inverters and storage systems for every segment. So whether your project is in a residential segment, or you are designing projects for CNI and or utility, you always find proper or suitable product in our portfolio. Having said that, it means that you actually can get all the components, all the products from one source. Today, we are focusing on the design tool in combination with our solar modules and inverters. But regarding design tool, my colleague Nicolas will be talking in the next slides. Now, let's simply move to our module portfolio. And here you see the main products overview of this year, starting with the small size modules, as we call them, on the level of 450, 460 watt, with either all black version or black frame version, and 25-year product warranty in standard, which is very nice. Up to the largest size of module, over 700 watt, which is very suitable and a very favorite product for large utility projects. Most of these products are using TOPCon technology, but Canadian Solar company is unique, offering also other technologies for you, whether it's heterojunction technology, or whether we are offering you special products like anti-dust or anti-hail. Especially anti-hail is a very special product with the fire class A and higher loads with the frame thickness of 35 millimeters. So very strong modules, very suitable um, um, for the tenders. And this product can withstand a hail of 55 millimeters, so it's really robust. Or maybe you are a fan of heterojunction technology, as said, and that would be the second product from the right side, High Hero Plus. And with this product, you get a little bit higher power class. You get a little bit longer product warranty compared to our standard warranty, which is 12 years. With heterojunction technology, you get 15 years. And what is very important to mention is the temperature coefficient, which means that with heterojunction high hero product, um, your your system would be generating more electricity if you compare with other technologies like Topcon. So it's a very interesting product to be considered. Now let's move on to our inverters. As said, since already some time, Canadian Solar is producing our own inverters, and our inverter portfolio is a series of 3-phase string inverters that are ideal for rooftop and small to medium ground mount applications on commercial, industrial, as well as utility applications. They feature multi-MPPTs with a maximum current of up to 32 or 40 amps per MPPT and a patented cooling technology for long-term reliability. Here you can see the list of our inverters starting on the level of 15 kilowatt up to 350 kilowatt. So we are sure you can always find a proper and suitable product for your for the designing and for your project. And these inverters are coming in standard with 10-year product warranty, which can be further extended up to 20 years. I would maybe mention that this slide is very important. So let's stay here for a while. Technical support. As always, we are glad that our customers are buying our products, that they are buying our modules or inverters, or they buy all of them. But here and there, you always can get into a problem, and it always can happen among all those hundreds of gigawatts sold products that some units of pieces are broken or simply not functioning properly. So then you can always rely on us. Then you can always rely on our support. And what is very important to mention here is that at the end, we don't really care if we are being approached by the end customer, or if installer is approaching us, or if it's our local distributor to approach us. For us, the only thing matters, and that is that you are using our product. So we don't differentiate whether you are end customer, installer, distributor. You can always approach us directly, and there are various ways how to approach us. So if it's convenient to email us, feel free to do it. If you want to use our official website or hotline or mobile app, feel free to do it. We are here to support. I already mentioned a couple of times that Canadian Solar is a module, inverter, and battery solution manufacturer. And that is giving you some benefits buying all these products from one manufacturer. And that's definitely streamlined purchasing. That would be faster turnaround, faster process of the order, and logistic advantage of delivery at the same time from the manufacturer. So we have direct manufacturer access. And of course, you will be always talking about high quality standards on our side. Not to mention, but very important, optimal component compatibility. With our products, you don't need to care. They will be always compatible with each other. And here, this would be my last sentence of this slide and of my part of the presentation. You can always rely on our support. We are always happy to support you. Thank you for your attention. Nicolas, it's your turn.
Thank you, Marian, for the presentation. As said by Marian, I will be presenting a demonstration of the Canadian Solar design tool to see how we can combine or better combine our modules with our inverters and design fully optimized systems. I will share my screen here. Hope it's visible to everyone. Here we go. Full screen mode. Okay, we will share the link and details afterwards. Just a couple of key points. The tool is free for everyone. We have made it available. We have made it available, and then we have made it open and free for everyone. And you can just click on the link that we will share, register. There is an email address. You just set it up your account, and there you go. I have already my credentials, so I will just log in, and we will see how the tool is structured in two main parts. Well, first of all, in the menu, you can choose your language. You can modify your account credentials. Everything adjusted as you use it and as you prefer to adjust it. And as mentioned, we have mainly two parts here: the plan configurator, which is kind of the home of the tool, and we've also have the string tool. The battery tool is something we are being currently optimizing. It's not recommended to be used right now, but we will. We are open to share something around it if there is interest on storage in general for these kind of projects. Please let us know, drop us a line, or directly ask us. We can organize something separately, or maybe another webinar, something like that. We are going to start with the string tool. The string tool allows you, basically has a very good advantages that allows you to configure in a very simple way one system. If you click new, we start with a new project, and in a very few minutes you can, with very few inputs, also get a very good information, a very good output data of what you're going to produce with your system. To create the full project, we are just going to start with the location details. So a name for the project, string tool, a reference, which is going to be maybe October 2025, and a description, Canadian Solar, modules, and string inverters. Here, when we get to the address, this is a very important point. If we have the exact address, it's always better. Otherwise, we can just include a nearby town or city or whatever. This is, I'm just going to include a city here, Quest, for example. And this is very important because it gets meteo and irradiation data from PVGs in this case, and including also temperatures, which are very important to calculate open voltage, open circuit voltages, currents, etc. Once we have inputted the location details, we can go to the PV fields, so defining PV fields. We've got the option here to define up to 3 different inclinations for PV fields. In this case, I'm going just to use 2 of them, just to show how it works, considering also now that we are going to do kind of the same project in the string tool and in the plant configurator. So to define the PV field, first we have to include the azimuth and the tilt. We can click in this interrogation point and we can modify this manually this way, or just include a number or an angle here. For example, here, if you're going to consider a flat roof in an industry, because we're focusing on commercial and industrial installations, can be 15 degrees. Once we have it, we can just close it and we choose the installation type, which is now roof mounted. There we go. Here we have made available the option to use a custom module. Is the only part or the only place in the whole Canadian solar string tool where you can choose another manufacturer's module if you want. This is because many customers are using our inverters and maybe have already installation or want to combine different kinds of modules with part of a new installation, revamping, repowering, different kinds of options. So to use a custom module, just click this box. You have to create your new module, and our recommendation is to import it from the ENF database. You can click here, select manufacturer, series, model, load the content, and once you see the content loaded here, you just add it. It's a very good database, so we recommend it to use it. But anyway, you can also import a PAN file if you've got it in your computer, or you can just write every single detail here, every single data point. Anyway, we always recommend Canadian Solar modules. So we are going to use, in this case, our 54TM modules, series 510 watts, for example. There we go. And we're going to insert now number of modules, which can be, in this case, 624, which was the last used, for a total PV array power of 318.24 kilowatt peaks. Yeah, there we go. As you see, we have defined the first PV field, and then we just, if you want to activate more, we can just click here and define different azimuth or different tilt if applicable. In this case, we can, it's 15 degrees. Let's say it's looking in a different way, like 5 degrees south, and the tilt is a bit steeper, so like 25 degrees. There you go. We can set it as roof mounted. By default, we've got the previous configuration, so it makes this easier. Let's just say that this is 16 modules, just for us to see. And as we see, we have defined already the PV fields. So the next part will be the inverters. In this case, we've got this clicked, so we are only showing inverters in our market, or that are available in your market, specific market. And as you see, you can see all our portfolio here. For this installation, as we've got more or less 300 kilowatt peaks, we can just choose the 100 kilowatt inverter type B, which has 9 MPPTs. As you can see here, you get basically basic data from the inverter: input, output, number of strings you can connect, number of MPPTs, etc. So once you have chosen it and you have defined the inverter PV location details, you can click to next. Our recommendation is to fill every data point as it's shown in the system one by one. So following the order, taking your time, and doing it with confidence. Okay, so here we've got the number of inverters we can choose. We are going to choose 3 inverters with for a DC AC ratio of more or less 1.1-ish. Confirm. And there we go. Important at this point is to explain what this all means. Here we can see the 3 inverters. We can basically expand it and close it as we see, make it visible or not. But we have the 3 inverters that we have selected. We can add, modify inverters. We can also, if we are not sure about this inverter, we can go back to basic inputs and change it. But once we're sure we've got basically the 2 B fields that we have defined, one with 624 modules and another one with 60 modules, just 60 modules, and the type of module, azimuth, and tilt. In the inverters, what we see are all the MPPTs. Here we see 9 MPPTs, and also the 2 inputs per MPPT. Also on the columns, what we have basically are number of modules. What does this mean? This means that if we are, for example, in the MPPT 1 using one entry, so only the first input and doing a string of 20 modules, we will just click here. And we will see how we are assigning modules from PV field 0, so this one here. And we see how this number has gone down by 20. So this means that we have assigned already 20 modules, and we have 604 modules yet to assign. If we're going to use both entries of the MPPT and maybe do 2 strings of 14, we should click here. And we've got a total of 28 modules assigned to this MPPT in 2 strings of 14. And we have to do this for every single MPPT. There is an option to calculate this automatically. In this case, everything is assigned to PV field 0, so we have to assign some, at least one, to PV field 1 to make sure that we fill it. I'm just going to do a demo of the automatic calculation here. We click calculate. We will see how the system has decided to make 2 strings of 8 modules. This is honestly not fully optimized. I think it's always better to do this manually. You can just also do a couple of calculations with an Excel, or depending on the field, distribution. Every project is different, so best, in my opinion, is to do it manually. In this case, for example, we can just do one string of 16 assigned to this MPPT, and that's it. And for the rest, I know already this can be divided by 16, so I'm just going to do strings of 16 and using one or both entries of the MPPT. So for example, here we have got 32, so 2 strings of 16, here 1, and so on. I'm just going to do this very quickly, manually, just to show you how it works in general. I'm just going to mix. This is also recommended in our inverters manual. You will see there are basically recommendations for string distribution. If you have different strings with different number of modules, the idea is to always help the inverter distribute the heat, so it doesn't overheat in general. Anyway, our inverters are designed to work in high temperatures as well, have a very optimized rating with high temperatures, so no rush on them. Another point that I almost missed is the color code of the MPPT. So as you see here in this first green, we've got configurations of strings that fulfill all the requirements in terms of voltages, currents, and power for the entry, for each entry of the MPPT or for the MPPT. If we see this kind of brighter green, we are basically entering into configurations that are fulfilling voltage requirements and intensity requirements, but are not fulfilling fully the power requirements. So, in other words, there is an overload of the MPPT. This is fine up to a certain point because our inverters can take up to 1.5 DC ratio overload, which means that basically the system is telling you that there is an overload in these channels, but you can still use these configurations. When you go further, so when you overload the MPPTs by more than 150%, The configurations that show in yellow won't allow you to move forward. So this means that we cannot ask this amount of modules into one MPPT because you're overloading it too much. You can also change this overload DC AC ratio. Now I set by default in 1.5 because it's what we saw in our inverters manuals and the data sheets, what our inverters are prepared to take. But you can also reduce it if you want. If you want to stay under 1.3, 1.2, up to you when you design the system. Also, feel free to contact us for this. Important here, well, as we see in the PV field number 1, we have already assigned all the 16 modules, but on the PV field 0, we have minus 16 here in red, which means that we have assigned 16 more modules than we had. So we have to take away one string of 16, like this, and then we see how we have assigned all modules for both PV fields. Once we are sure about this, we review and we click next. And here we will already see kind of a yield result. Also important to mention that all these results are verified and certified by the Fraunhofer Institute in Germany. They're even bankable, so all the yields and the production results that you get from this are proof, are reliable. As you see, you get a summary here of the installation, input data that you included, PV fields, production, performance ratios, energy, global irradiation, and more information, as well as the configurations of the inverters, which all the values, all the strings that you would include per MPPT, also the field that you're taking the strings from, and all relevant values basically for the inverter, and all the strings. You can actually already export this into a PDF by clicking this printing button here on top. This will generate a PDF report. I will show to you here. I've already downloaded several reports that the system is generating just to show you. And as you see, you can see a summary of what we saw already in a bit more of a better layout, basically. There you go. The new one has downloaded, but yeah, basically you see the result, and you can even share this with us or with the client, so we can check the system and maybe we can align on what the possibilities are and how we can better optimize the design and the usage of our products. If you want to go a little bit further in the analysis, you can click here the Add Self-Consumption tab, and as well as the Add Financial Study tab, and you can go to next, or just click on the tabs on top. We'll see it above. The Self-Consumption tab allows you to go a little bit further on the analysis, also including the consumption of the client. You can do this kind of by letting the system calculate it. This is very useful for residential, but honestly for CNI projects, we normally have the profile, the load profile of the client. To upload the load profile, it's possible to upload it in CSV or in Excel. The important thing is that the file must contain only one column, and column A, basically, with all the values of the loads per every hour. So 8,760 values in kilowatt. To do this, once we have the file, I have several load curves here. We can just load a curve here, for example, which is 400 megawatt hour per year consumption for a typical industrial client. Once we get there, we can the system will tell us when to reload the graphs or to reload anything in general that the system needs to calculate. And here we go. So we can first view our consumption profile. As you see here in January, it looks like this. Start of the day, maybe the production starts, then there's a pause to eat, or a pause for the production, then another peak in the afternoon, evening, and then the manufacturing may go down during the night. So the consumption goes in that line. If we want to add storage, we've got a simple calculation here. I'm not going to click it now because it's not dedicated to this at this point, but please, again, let us know if you're interested. We can organize something around that. As you see below, the system is showing us the data per year in terms of where the production goes and then where the consumption goes. So, for example, in February, we've got a monthly production, normally I like to see it in average production. So you can see the average per each month or average consumption per each month. And the most useful thing, in my opinion, is to see the average production yearly. So you see here that if you make an average for all the days of the year, it's going obviously to be different for every day of the year. But basically, this shows you the generation curve in this pink color, and then the consumption in this blue color. And then there's a color code as well that is explained here. Is in line with the breakdown that you see on the right hand side, where we have a PV production that goes to self-consumption. 42.6% of the production goes to self-consumption, and the rest is injected into the grid. In this case, might be interesting to use a storage solution like our KuBank solution that you might be familiar with, and we can dedicate a webinar to in the future. Same for the consumption. This is going to explain us where the consumption is taken from the grid or directly from the PV production. Once we've got this, we have to save here on top. And by saving, we are enabling the financial study of the system. Also important to mention, this is an online tool, so you don't need to download anything in your computer, which is generally very handy. It's very, very useful. Sometimes, depending on where you are, the connection you have, it may take a little bit more to load, or a bit less. But generally, it works very well everywhere in Europe. So here we see the tab of the financial analysis. We have to include some input data. In this case, we are going to see an economical analysis in 20 years. We can modify this, and currency, we are going to use euros. The PV system costs, we can include them in a detailed way, which means that we will include unit costs per every single component of the system, including also mounting or installation or every different costs. Our recommendation anyway is just to use the specific investment costs at this point of detail that we are using. So it would be a cost in euros per kilowatt peak. I'm just going to use random costs here just to show you how it works. Please don't take this as fixed or as something from the market. It's just to show you how the system, how the battery works. So we are including a cost in euros per kilowatt peak that then is translated into a total initial investment below. For the battery, we are not going to look at this now, but it's basically designed to help you understand the cost of replacing the battery in case there is too much degradation and so on. Regarding financing, we are also able to include an amount that is being financed, maybe by a bank or by an investor or whatever partner. And also, if there are grants available in your state, region, or by any institution, you can do that by a total amount. So if I don't know, the region is supporting me with 30,000 euros, you can include it here. Or you can also include a fiscal deduction for a number of years. I'm just going to include this here to show you again how it works. Once we've got this, we have to include the electricity prices, general average price per purchasing electricity and for selling electricity into the grid. I'm just going to leave it as it is. I'm not going to enter into details. In case you have a feed-in tariff, you can also include it. Annual price increase, since 0 here, let's just put 0.5%. And then feed-in tariff direction. I will leave it like this. And then, as mentioned before, the system is asking us to update it so it can calculate the return of investment. This is generally very useful for clients, at the early stage of their planning of the system. And as you see here, you've got a summary of what you're going to produce, the system is going to give you in terms of income or savings, and generally the yearly return rate, which in this case is 6.67%. It's also generating a curve for us with a cash flow, with also a color code here that it's explaining you what everything is. The blue color is generally the cash flow. We've got also the grant that we include of 30,000 in the first year. And as we see, we are recovering our money in this case in year 5, or the client is recovering the money or the investment in year 5 or 6. We can also print this a little bit more complex or more a full study of the system by clicking the printer on top. You can also contact us by using this button, or just drop us a mail. Just write Marian a mail, or you can even share the documents for us. The documents that is generated is including the configuration that we saw before, and also the self-consumption and the financial study details. And with this, it's always taking a little bit more time when you have to explain it. But as you see, once we can save the project, but it really takes very little time to check a configuration that we have or a project that we are considering with Canadian solar modules and inverters. So, including also here in the support that we are aiming to provide to customer every step of the way. So with this, we've got the string tool. We are going to go now into the plant configurator, create a new project. In this case, the plant configurator is prepared to, I'm going to remove the labels of the map, just in case. But yeah, the plant configurator is prepared to help you build a project from scratch. So this is including already a higher amount of details. So a bit more complex in terms of design, but also giving a little bit more precise information. I'm going to go to give the basic inputs to this project, webinar October, basically 2025, and then Canadian solar modules and inverters. Here I'm going to include an address I had already seen. We can move in the map. This is basically Google Maps, but in this case, I have already seen an address before, and I have prepared for this. Important thing here is that we place this little blue flag into the installation that we are going to work on, into the building that we are going to work on. We can do this by just selecting the flag or moving it around, or just by moving around the map and double-clicking in a building. Again, I have prepared for this building, so I am going to place the flag in the center of the building. And important as well is to adjust the zoom more or less so it covers the whole building. You could do it like this, but just give it a bit more buffer. And when we have adjusted the zoom and the center of the building, we can click on top, create. Again, this is a bit more complex in terms of the data that the system is taking into account, obstacles and physical objects on the terrain. So it might take a little bit more time to load, but anyway, again, everywhere in Europe is working pretty good. We have two options here for the basic layout. As you see, the system has cropped the building that we are going to work on. We are showing below on the bottom, basically, of the page, on the right-hand side, we can choose to see the sunlight. We see here it's prepared for one day of the year, 21st of June by default, and by midday. We can move this to see how the sun is going to move during the day, shadowing, and so on. But anyway, our recommendation here is just to use these two little arrows, which is a top light, which improves the definition of the sketch and help us work on the top. We will see later we have a 3D view on the bottom left, as you see here. We can change the light and so on. But generally, we recommend working or preparing the things in 2 dimensions. On the menus that we see on the top right, we've got one menu for terrain util. So we will see now how we start with the shapes of the buildings. Then we have the objects of the building. Then we have the prototypes that we can create here for the modules and the structures that will then appear into this menu. Then we can do some shadowing analysis if we want, not needed, because the system is anyway doing the shadowing analysis when it's generating the results and the report. And then finally, we go into the inverters or the electrical configuration, where we will see how we can choose inverters and then more define basically the string and the configuration. On the terrain, we generally work always with the sketcher that you see here. And we have several options. We've got default shapes. We can also go with the sketches here. For example, if we would have this whole building with irregular shapes, we can just go on the vertex, click with the left bottom of the mouse on every corner, like here. As you see here, we will see if we click the Alt button, we will get 90 degrees angles, and these 90 degrees angles are shown in the tool because you will see these little kind of crosses, black crosses on the vertices. As I said, we can just follow the shape here. If we were to include, I don't know, a bit more complex shapes here or there, we can do this. I'm just going to do one random shape here so you see it. Obviously not going to use this. We could move it around. We could rotate it later, yeah, as we will see here. And in this case, we're just going to delete it because it's not the shape of the building. Another option is the predefined shapes, which is the thing that I'm going to use for this one. So I'm going to adjust this to the vertex first. I'm going to go into this vertex by clicking on the shape, and then I'm going to rotate it to align it with the building. I know already the measurements of this. Oh, sorry. See, again, if we are into rotating mode or into a mode and it does something that we don't like, we can just go back, click anywhere in the map, and then go back to the shape and start again. There is one point we are trying to improve. We were honestly explaining the pros and cons of this. Everything is a pro. Generally, the only con I see right now is that there is no a Control Z or an undo option. Pretty open about it in general. So, but anyway, we can just go back pretty easily. And as the more you use it, basically, the better you get at it. As said, I already know that this is 138 meters because I've measured before the webinar, and so I'm just going to click there and write the measurements of the building. It's always better if you know the exact measurements of the building, and there you go. Here, this is a typical issue that we may face, and this is that basically the shape is or the site is kind of taking a measure in the wrong direction or the measurement we didn't want. Again, we can quickly just delete this shape and very quickly include in another one. And what we can do here is to adjust this in a different way I wanted to show you. So we can, when we go to the menu, click Edit Vertex, Move Element, and we can just take the side and bring it to the other side. Same with this one. We can also edit again here when we unselect this vertex option, and we can say here 137, just 138, 138, and here 31 and 31. Same issue. If we have the same issue again, we can just edit all the vertices again. And as you see, eventually we get to the shape that we wanted. And again, looking for the very precise 90 degrees angles. If we want, we can go to the level of detail that we want in any case. Once we're okay with the building, we can just go to create with the shape. Sorry, we can just create the building. In this case, we can create this flat building. I'm just going to give it a height of 10 meters, for example, and parapet of 0.3, create building, and you see how easy it has been in this case. If we want to move it once the building is created, we have to go back to the shape. So click on the building, click on shape, click here and move it around. And then click back on the building shape. You will get the recording so you can check then every kind of control that you will see in the webinar. As mentioned, I didn't mention that we can move around the map as well by clicking the little wheel on the map on the mouse and then moving the mouse around. I'm going to quickly create another shape here to show you the two PV fields and a different type of building. There are many different types of building. It's impossible to cover everything in one webinar, but we just try to cover as much as possible. So then you can use it on your own and get to discover all the possibilities of the tool. Again, we create a building. In this case, we could create a residential building to show the slopes because this is a dual slope, or we could go into the industrial building and choose the shed slope, the slope option, sorry. This will give us a sketch. Normally, we recommend to include the input data as number and a gap. You will see the number means the number of double slopes that we have. So every roof that you see here, in this case, there are two. We can just include one. And then every measurement is included here. So for example, E, in this case, it's going to be 0. Wall height is going to be 8, okay. Roof height is going to be 2, whatever. And parapet is going to be 0. Once we create building, we have to select one side. Also, the sketch is telling us where the building is going to start to be created from. So in this case, we can choose this side, and we will see how in the 3D view we get all the building. Next, I'm going to speed up a little bit so we finish in time. We can activate the transparency of the building so we can include the obstacles. To include the obstacles in the building, we can just go to the roof objects. Normally, we recommend this obstruction here. We can place it on top of the obstructions that we see in this case. We can modify this by clicking on the scale. So we can adjust this to the scale of the object. And we can also duplicate it. If we select this button, we can just take another one and put it here. But there is a smarter way to do this when we have symmetrical kind of configurations. So as you see, this red arrow is always the x-axis. The blue one is the y-axis. It's positive, can be positive and negative. I know already here that the distances between the object. So I'm going to include from the origin to the next origin of the next object is going to be 12 meters, and there are 11 objects. Here it's going to be 15 meters, and there are 2 objects. So if I click duplicate, we'll see how automatically this generates all the objects for the building that we have. We can also include the external objects if we want. For example, in this case, we like the maple tree because we are Canadian. There are some trees here, so I'm just going to include one here just to show you how it works. Again, here 3D view if possible, but let's just go to the prototypes. For the prototypes, we are going to create 2 prototypes, one for the little building, which is going to be this kind of slope mounting, choosing the 54 TM modules 510, create prototype. And then we're going to go back and create another prototype. When you go into the structures, you can see that we've got a tracker option for our installation with trackers, but please go to custom structures when you want to see other kinds of installations. This one is going to be for the flat roof, 15 degrees, same module because we had it already selected. And we're just going to go to the prototypes and place them here. To place them, we just click on the prototype, in this case, flat roof, and we click here. We can, on top here, fit selection, keep offsets to the areas. Let's just give 1 meter per vertex, so you see the area is reduced, just to avoid having them on the edge, having the modules on the edge. And then we can just add just the maximum kilowatt power that we want. If we want a limitation, the maximum modules that we want here. Again, if we want the limitation, I think earlier it was 6 to 4. I don't know if they're going to fit, but just including the maximum just in case. We can also include a maximum number of modules per row. I will put 8 in this case, and distance, horizontal distance between rows. I'm just going to put 0.4 in this case, so to have some spaces and for maintenance and so on. If we calculate this automatically, it will orient the modules to the south. But in this case, if we want to orient them to one edge, we can just click on the edge that we want to orient them to. I'm going to click this edge, and as we see, we've got here 598 modules arranged in the roof. Once we are sure about the placement, we click on place, and we will have them here, basically based on top of the building. Same for the little roof. I'm going to select now the slope mounting, and I'm going to put them in this slope here, maximum of, let's see, 16 modules, and I'm just going to do the same, 8 modules per row, and a distance of 0.4. Calculate. Here we've got 2 rows of 8 for this little building. When we are sure, you just click place, and there we go. We can now see the 3D view. We could make a shadowing analysis. If you are not sure where to place the modules, you can go to the surface irradiation, field selection, select it, and the system will automatically simulate the shading when we click it. Or we could do shading by slope. Different slopes have to be analyzed separately. In this case, we are not going to do it because there are not relevant shadings, so basically the shading is going to be, there are not going to be very many lost by shadings. We will see it in the report. When we go to the electrical configuration, we just click on the slopes that we have worked on and click below on string design. In this case, I'm going to select again 3 100 kilowatt inverters type B, calculate, and this brings us to a little bit more complex, but basically the same idea of the configuration that we saw for the string tool. I'm just going to select 3 inverters. I'm going to do it very quickly in this case because it's we have already seen it, and to just being conscious of time. So here it's going to be 16. Here I'm just going to do it automatically. So it quickly does the configuration, and then I'm going to apply it to all fields. You have to click twice the apply to all fields. Sometimes you get you can get a little message if the tool is taking a little bit more to load. In this case, I'm streaming, so it might need a bit more speed. But anyway, eventually it works. Just click on assign to all fields, and you'll see how the system calculates all the strings and all the cabling, kind of minimizing the cable length of the installation. You can also select drop points. If you click here on select drop points, it will show you these little white balls that show where the cabling is going down, so where you will place the inverters. You could move this around and then assign again. In this case, I'm happy with this configuration, so I'm going to save it, save configuration. This is going to already create my project where I can click on the configuration on this menu here at the very end. Click on summary, export drawings if you want. Yes, select the configuration. We can have many configurations in one project and export it. This has already generated all the results, so we can trust again these results certified by the Fraunhofer Institute are real, are trustable, and are even bankable. Here we will see how the system already generated a little bit more of a complex report for us, where we will see the yield. It's a little bit more visual. We can adjust the image as well. This can even be shared with a customer if you want. And you can see also the configuration of the inverters and the irradiations that we expect. As we see here on losses for shading, it's really low. It's really low. But we get a very good breakdown of information. We can also export the data in Excel. If you click here on top, we can export the data in different parts. We can even download already this report, which is showing this information. We can see the technical drawings that the system has generated. These are the physical drawings of the roofs that we can export in CAD, as well as the electrical design, which includes all the stringing, minimizing the cable length, and a very simple single line diagram. We can export as well this in CAD format. We can also see here the self-consumption activating here, self-consumption and financial. I'm not going to go to the details because it's basically the same that we have just seen in the previous slide, in the previous part, the important thing that the new thing that this offers is basically the bill of materials. So here we could include all materials that are being used in this system. It's already included the ones that the system has used. We can also include other costs, adding a new here that, as we see, like installation, markup, discounts, etc. And this fits in then into a commercial offer that we can download, fill in all this data. We can save and export. I have an example here that I have downloaded previously, and this is basically showing a little bit more detail. It's a little bit more visual. Obviously, here is empty, no customer, no address, anything. You can just share it directly with the customer or with whomever. We cannot see this. It's important. The only thing we can see in the tool is basically your email address and the number of projects that you have done. And that's it. I'm quickly going to exit this full screen mode. I've seen some questions popping up, so maybe Marian, sorry for the time, but maybe we can answer a couple of questions from the audience.
So let me read it for you. Is Canadian Solar manufacturing the inverters? Yes. Yes.
Again.
The answer is yes. Canadian Solar designs and manufactures its own inverters. No third-party OEMs are involved. This ensures full integration with the company's photovoltaic solutions and leverages over 2 decades of solar innovation since 2001. Let's check another question. Warehouses. So the question is, do you have local warehouses for quick delivery of modules? Yes, of course. As we already discussed, we have several warehouses. We have 2 of them in Europe. So one would be Koper in Slovenia, and the second would be Rotterdam in the Netherlands. Then we also have Dubai, and we also have Cape Town and Durban in South Africa.
Yeah.
So
I see
let's.
other.
Nicholas, yeah.
There are a couple in the Q&A that I wanted to. We won't manage to reply to all of them because it's already time, but just a couple of that very quickly. The rest we can reply them privately. But someone is asking if the system only works with Canadian solar inverters. Yes, it works only with Canadian solar inverters. The plant configurator also only works with Canadian solar modules. The only place in the tool that you can use Canadian solar, something that is not Canadian solar, is in the string tool for other modules. Basically, thinking about the revamping or repowering projects.
Then, if no more questions, then thank you very much for attending this webinar. And of course, we'll share all the slides and information with you by email.
Thank you.
Thank you.